First of all, thanks for joining the webinar today. My name is Sachin. I'm working as an assistant of the manager with Beinex, handling cloud and data analytics implementations across the Middle East region. I'm going to be joined by Rahil from Redington, and we'll be walking you through to some of the best DR practices on AWS and the benefits of DR on the AWS cloud. I think we have some more people be joining in, so we'll be waiting for the next be 2 minutes, and then we'll proceed with the. Hello, everyone. Good morning. First of all, thanks for joining the webinar today. Am I audible?
Yes, you are.
Rakesh, there seems to be an echo in the voice.
Is it okay now? Is it still there?
Yeah, it's still there. The voice is heard 2 times.
Okay. No, there's no issue with your voice. It's completely fine.
All right. Thanks a lot.
All right.
Hello, everyone. Good morning once again. My name is Sachin. I'm working as an assistant manager with Beinex. I'm handling cloud and data analytics implementations across the Middle East. I'm going to be joined by Rahil from Redington, and we'll be walking you through to some of the best DR practices on AWS and the benefits of DR on AWS cloud. So this will be the agenda that we'll be walking on you today. So first we'll start with an introduction to our company, Beinex, and then we'll proceed with the generic on-prem infra challenges and some of the benefits on AWS. And we'll see, how, we'll plan for a pre-DR modernization to the cloud. And over the course of time, we'll see the benefits of a DR on the AWS cloud, the multiple different DR models on AWS based on the complexity, and the AWS way of doing a DR with Cloud NDO. We'll be showing some of the technical artifacts about the tool, followed by a short demo of how a DR and replication can be configured by using Cloud NDO. Post that, we'll be taking your questions, if you have anything of that sort. So first, we'll see an introduction to Beinex. So we predominantly started as a data analytics, prescriptive and predictive analytics company, and we are the only gold partners of Tableau and Alteryx in the Middle East region, with a successful track record of 250 plus man years, with about 180 plus successful implementations across the region as well. And we have also diversified our service portfolio by being one of the premier select partners of AWS. And we have completed multiple successful cloud implementations across the region as well. Apart from AWS, we are partners with Microsoft for Power BI and Azure implementations, with HPR, a real-time data replication tool, Snowflake, the most in-demand cloud data warehouse, database, and data mart clubbed all together, and Salesforce as well. So this speaks on volumes about our service blueprint and the multiple different technologies we have our expertise on. So we'll move to the next slide. So this is some of the services that we have been offering in general. So we are into, consulting services with audit analytics, risk analytics with roadmap, and with data, with governance, business intelligence, and so on. We also do product and support on AWS, W, Alteryx, Microsoft, Snowflake, HVR tools, and with project management as well. We do co-sourcing on risk analytics of the roadmap, gap analysis, data governance, data warehousing, business intelligence as well. At the same time, we do a training for the enterprise risk management and analytics, data visualization using Tableau and Power BI, prescriptive and predictive analytics will be using Alteryx and business intelligence as well. So before we start with the DR, we'll see some of the on-prem infra challenges in the generic terms and the benefits of AWS. How AWS solves those problems. So this is a generic slide, which we talks about some of the on-prem infra challenges. As most of you, we can see are from the IT backgrounds, you might be wary about these terms as well. So first and foremost, when you are setting up, a physical infrastructure, the first thing that will be coming into consideration will be high cost. You need to be thinking about setting up a data center, a physical data center. It should be having a perimeter fencing. You need to be thinking about the traps and the different security mechanisms available via the data center. And then we need to be investing about the data center technicians, who are giving us access to the data center for so and so time. So resources also something which comes into play. And then for a data center, you will be considering about the data center facility as well, and that will include the the power distribution of unit, your server space, your crack units, your AC and cooling of systems exclusively, and your racks, your biometric systems, the smoke detection of systems. So basically, you have to invest in overall, landscape to be hosting an infrastructure on the on-premise. So cost is something which is, very challenging for somebody who's starting with this. And the next thing will be about the flexibility. If you want to make the changes in short notice on your traditional on-prem data center infrastructure, it's something which is really a bit difficult. If your application needs some sort of change, you need to clone that application, then do some changes, and then put that changes back to the previous server. So all those things will be manual. You need to be talking to your server team. You might need to involve the storage team. So multiple levels of hierarchies or silos that you need to follow to make any changes to your infrastructure. Next thing is about the scalability. And if you want to scale your resources overnight by adding, let's say, 100 more servers. Tomorrow mid-morning, I need to be having 100 more servers. And if you want to do that, scaling is something which will be a real tedious process in the traditional DR data center, because it will take a lot of time. It will take a lot of effort from people who are doing this, and so on. And the next thing will be the time to market. If you need something, a new infrastructure or maybe a new code deployed in a matter of minutes, that's something which is hard to achieve with an on-prem, a physical data center infrastructure. So that's something you need to be considered as a big challenge. And the complexity, you need to be thinking about the resources, how much time you'll consume to maintain them, and you need to deploy new technologies, wherein you have to issue a purchase order, you need to get that new box or a specific technology implemented. And then that adds to the complexity as well. Now, over here, we see, how AWS solves most of those problems. So we have broadly classified some of the benefits into strategic, operational, and financial. As far as the strategic benefits are concerned, in AWS, we just have an AWS console where users will log into it, request for resources, pay their bills. If they want to assign some stories, they can do it on their own. If they want to add an big card, they can do it on their own. So a lot of dependencies actually being produced with this. And talking about the security, because if you have a DR data center on-prem, the first thing that comes from the first sort of a question that it comes from the customers, it's about the security of the data center, and you need to be investing some time and effort in auditing the data center, maybe an ISMS, TVRA, or a SOX audit, and you need to be sending those reports to the client as well. Though most of us are doing it, but that's again a tedious process involved in this. So in AWS, we are not worrying about anything of those. All the data centers are certified. The audits are taken care by AWS. The data is secure to be transported. As a user, as someone who wants to start an enterprise or get into digital transformation, you don't have to think about security aspect as well. Obviously, it's future-proof because in the ongoing coronavirus pandemic, it was difficult for most of the customers, here and all over the globe. And let's say if I have my physical data center available and everybody started working from home, sending a data center technician or a touch hand of a support person over to the physical data center to turn on or maybe do a hard reboot of a server if my application is not been working has become really a bit difficult, or maybe impossible, as well in the pandemic situation. So investing in a future-proof solution like AWS, you don't have to worry about any of these. If an application is been working, if a server needs a reboot, as a user, you can just log into the console. You can do anything of your own as well. And now we'll see the operational benefits is pretty much self-explanatory. You can consolidate, you can scale your resources, and it's all agile. So when we say consolidate, what we mean is that you have a console where you can request for server storage of the network resources on the go, and you are kind of bypassing the traditional silos of requesting for a storage or maybe making a network being changed with multiple internal teams, and the big challenges that comes with it. You might be following a change management process. There'll be a change window for your dependency teams as well. Let's say if you're sending a firewall request today, your network team will be processing that tomorrow morning, and that adds your challenge for your urgency of making a change to your application or introducing a new application, a new software, and so and so on. About scalability, if your application needs some more resources, there is a peak time, let's say from 10 a.m. to 1 p.m. and you need to buy your application to be automatically scaling based on the load to the application. In AWS, we have auto scaling groups, which can do the trick for us. As far as agility and speed is concerned, it's pretty much agile. You have AMIs, AWS machine images, which can be deployed. Those are predefined images that you have on the AWS workspace or your local workplace. So you can just select if you want a Windows machine or a Linux machine, and then the machine is up and running in about 2 minutes. So that's pretty much with Agile, and you can carry over your testing as well. And over the financial benefits, you are paying for what you use for the type of AWS instance that you select. When you say an instance, we have multiple instances, T, R, X, M, and so on. So every instance will have a certain amount of CPU memory and storage associated with it, and you'll be paying for only the type of instance that you've been selected, and for how much time the instance is running. If you are turning off the instance, obviously not going to pay for the computer resources, except for the fact that the storage charges will still comply, because the next day morning, if you are turning on the same resource again, or maybe using an ABS mid-volume, which is like a virtual mid-hard disk, that needs to be preserved. The data on that needs to be preserved. So the storage charges will be complying there. But in general, you're paying for only what you use. And obviously, there are no setup costs as well. You don't have to think about anything else. Otherwise, you have to think about buying the server hardware, the hypervisor for creating your virtual machines, your network devices, your SAN boxes, your network cables, the power. Everything needs to be taken into account if you are doing it physically with setting up a data center from scratch. But in this case, there is nothing of that in sort. Over to the DR modernization challenges and objectives. So we have broadly classified some of the objectives or the reasons why an organization will be thinking about implementing a DR solution. So it's more about the scalability, elasticity, resiliency, efficiency, and enablement. So scalability, as we already have discussed, based on the leading up demands of the business, your infrastructure should be able to intelligently scale, and that's something AWS provides, or this is something any organization will be thinking of while implementing a DR solution. The next thing is about the elasticity. Whenever you need some specific resources, it needs to be available in one shot. Like we discussed already, if you need a network change to be done immediately, and if your network team says, no, we can't do this now, we'll be doing the change window tomorrow, that is not elastic, because you have to wait for them, you are dependent on them, and the ability of doing your work better is getting degraded there. The next thing is about the resiliency. Just to increase the availability of your technology, for AWS is about 99.99% of uptime guarantee that you get from AWS. Any mishap or accident or a natural calamity that happens to AWS data center, your data is not lost. How this is achieved in an AWS data center, the data that you have stored there is replicated across 3 different zones, maybe in the same region or multiple regions as well. So your data is throughout the year, every minute, every second available as well. As far as the efficiency is concerned, it's about the cost reduction. You're not paying for something higher. You're only paying for what you use on the AWS, and that saves a lot of costs as well from your budgets. And for the enablement part, which we think is the most important part, as far as the reason of the times are concerned, when we all got struck with COVID-19, every organization wants to enable digital transformation, and with an on-premise data center in the DR, infra, that's not going to help us to move to digital transformation are the pioneers in the technology as well. So we have all those things available in our AWS, and all these big facets of why we want to set up a DR is covered with AWS. We'll see some of the pre-DR monetization of the challenges. It's, I think, pretty much self-explanatory. The major thing will be the environment. Then you need to consider where your data center is hosted, exclusively your DR data center. Is that prone to hurricanes, flooding, or other kind of natural disasters that can impact at any time? And about the geographical things that need to be considered. Obviously, if you're hosting a data center on right in the middle of the desert, you're going to be investing more on the cooling as well. If it's right in front of a direct flight path or a major highway, or maybe somewhere deep inside the forest, or even Microsoft has these data centers underwater as well. So all these things need to be considered as far as the geography of your DR data center is concerned. And about the facilities, which I think everyone will agree to it, you have to invest a lot of money, or maybe budget need to be retrieved for setting up the data center, exclusively the power, HVAC, cooling, and the people cost. Because just implementing a DR will not be suffice. You need to be touch hand up with support and people, readily available at the data center to be supporting your DR infra as well. And these are some of the common major problems that you will be considering to resolve. So the first thing will be to securely transport data, because you cannot just transport data over the internet all the time. And over the VPN, though it provides you some sort of security based on your network bandwidth, transportation of data will be slower, and you need to consider that as well if you are, create a DR on the cloud as well. In AWS, we have options with AWS Snowball, Snow Mobile, transferring acceleration, where you can transfer petabytes and exabytes of data in just one go. So data transfer, which takes about, let's say, 100 days over the internet, and the VPN will now take about 7 to 8 days to do that. And in a DR environment, when the initial data set is complete, you need to be thinking about the seeding as well. Multiple synchronizations are available, be it asynchronous or an asynchronous replication from your production to the DR infra. Always the seeding should be active and intact, so that you're not losing your data. If you have strict RTO and RPO guidelines, you can stick to that. And the other thing will be to avoid paying for unused compute. If you have a physical DR data center, you might be having a big Dell server with about 128 GB RAM, or about 3 TB of hard disk, and about 24 cores, but you are just doing a DR for 3 virtual machines. So you have the compute there, but you're not fully utilizing it, and you are paying a lot, obviously, to maintain that device, and the hypervisor charges every year, and so on and so forth. So all those things can be avoided in the DR monetization with AWS. The next thing that you need to consider is about the multiple replication use cases. Some applications might need a synchronous replication. Some applications might need an asynchronous replication. Let's say for a specific database, your primary and the secondary database should be synchronously replicated, but you have a free, replica in case of an Oracle or a SQL database. You can go with asynchronous replication as well. So this is something that you need to consider when you implement a DR. And also for provision of resources, when the DR strikes, immediately it should be automated. The resources should be immediately available. The DNS should now be pointing to to the DR data center all in one shot. So there is a huge effort that goes into play with the automation and orchestration of the physical data center. And one of the most important things that we see from most of your customers is that they have different kind of a hypervisor, be it a Hyper-V platform or VMware platform. So when planning a DR, some customers might have both a Hyper-V and VMware as well. Maybe VMware on a more enterprise level with the mission critical applications, and Hyper-V onto some sort of development and test environments. So all these are Hyper-Vs or ESXIs should be taken into account when you plan about the DR migration. The migration should be supporting replication or data synchronization on any sort of hypervisor platform. So these are some of the overall problems that you need to resolve, before thinking about DR modernization. And over the next slide, we'll show you how easy it is to resolve all these problems in AWS. So we'll see some of the benefits of DR on cloud when compared to a traditional disaster recovery on your on-premise data center. It's about pretty much a self-evaluation here. The first thing that goes into place is the massive upfront investment in the hardware and setup cost. Once you have set up a data center, there are maintenance costs associated with the regular maintenance of the data center facility, the audits, the people, and the other factors that come into play in terms of electricity or servers, hypervisor, and so on. And whenever there is a growth in data, obviously they need more resources. If you're in the physical data center terms, tomorrow if my data growth is increasing, I need some more SAN storage. I'm just ordering the SAN storage today. It might take about a month or maybe at least 15 days for that sandbox to come. Then while it comes, you need to unpack it, set up it. Your storage team will be working on it. So you have to factor in about 3 days additional time in your IT plan to incur the extra hardware cost as well. And point number 3 is something which is the most important, what we have seen with our customers, because testing a DR with the physical data center will definitely cause a business disruption if you're doing it on peak hours. If you're not telling everyone, okay, I'm just trying to do a failover, obviously there will be a slight bit of a delay for the business users, will not be even worry about what's happening. So most of our customers ask us, is there a way we can orchestrate a disaster recovery without causing even the slightest of RPO degradation for a business user? And obviously the management and the infrastructure cost for setting up the data center as well. Now over to the right, we have the access of how a DR on cloud solves all these problems, wherein we don't have an upfront hardware investment. You pay only for the compute in terms of the CPU and memory or storage that you use. In AWS, a virtual machine is called as an EC2 instance based on the type of EC2 instance and how much is the configuration or the specification of that EC2 instance, how much time that EC2 instance is being run, is that turned off for some time. Based on that, we'll be paying for it. And there is lower IT management as well. You don't have to have a lot of teams working in a tandem, because somebody is an administrator good with AWS can manage just about everything, be it on the storage or network, and you can provide specific user roles as well. So let's see, the developers are given the role to provision they can add some sort of storage, but under a quota, and they can do their work. So you're just enabling them rather than making them wait or be dependent, with an IT for a team to provision their resources if they need additional resources. Again, that goes through all the approval, tedious processes, and so on and so on. And about the automation. So most of the DR environments are kind of a bit automated, but again, there are customers who manually turn on the DR and automation. I think they'll be a bit thinking about Python-based, automation, or maybe with some sort of a similar tool like that. But again, the data replication, the data validity is something I need to consider. And about testing, we need to do testing repeatedly. Obviously, that is going to cost some resources. You need to be creating multiple number of resources on your on-prem infrastructure. That's going to take some time out of you. And obviously, the system is up in minutes, on the cloud. If you request for a resource, less than 2 minutes, your system is in there. You're given a console to log in, and then you can do whatever you want. Because you have a public IP as well, based on the specific network security group, where you define your EC2 instance. You have a public IP from your laptop over the internet. That's something that's needed for most of us, as we are all working from home Wi-Fi, rather than an office VPN network. So in a nutshell, we'll see some of the AWS DR models, the spectrum based on the complexity and time. So from the left to the right, if you watch closely, RPO and RTO objectives from the left starts in hours. It goes to minutes to hours, and then it goes to minutes. It goes to real-time DR. So, we have put some dollar symbols as well there. That is to show you that the more complex is your DR infrastructure, the more cost is what you're going to pay for it. So, the first thing will be a backup and restore. That is a most common way with customers, who's having less RP and RT objectives used to follow. But for customers, who have an RP objective from minutes to hours, they'll be going to a pilot light with configuration. And for those customers who have really stringent RPO objectives in minutes, obviously they'll go for a warm standby configuration. And for real-time DR and replication, for those of the customers, they'll be going with a hot standby option. So the idea of putting up this slide is to understand that when we go from the left to right of the spectrum, if your RPO timelines are becoming very stringent, you're going to put a lot of money onto it. Your budget will increase, your cost will increase. And if you think about, for customers, having the option to choose what DR model they want. If it's a backup and a restore, option. So AWS provides something called as an AWS storage gateway, which comprises of the file gateway, volume gateway, your tape gateway as well. Now, what it does is, let's consider you have an EXXI infrastructure. From AWS, you'll get an OVF template, which you can import on your EXXI infra. You can create a virtual machine out of it. And what you can do is that you can create file shares on top of it. So it provides you a cache. And if you have an application, let's say you have an Oracle application, you want to save your Oracle RMAN into backups. Now, you will just import that file system on your Windows or Linux system, and there you go. So when you create a backup, that backup file is going to be sitting on that mount point or a specific drive, that file system drive. Immediately, AWS will save this backup file onto AWS S3. So what happens is S3 is an unlimited petabyte of storage. Locally, whatever files you save, automatically it will be going to the AWS through the AWS backbone of network. So that's the purpose of file gateway. And about a volume gateway, if you create a volume gateway with the same sort of setup, you have an EXSI environment, you deploy an OVF template from your AWS console, which you can download, import your vCenter infra. You on your data center, you create a new virtual machine, and you add some hard disk to it. And these hard disk, you can import your application as a SCSI target. If you have an iSCSI initiator installed, you can just scan for it, and you can discover the target on the volume gateway, and you can use that as a, let's say, for example, an E drive. Here on Windows, machines have been having a C and E drive already. You can use that volume gateway as an E drive. Now, what happens is if you save some of the files, or let's say you have installed your complete application on this iSCSI target that you imported through a volume gateway, what happens is this volume gateway is again replicated to AWS S3, which is the simple, scalable storage on AWS, unlimited amount of storage there. And if you want to convert this iSCSI target into a virtual hard disk, so in AWS terms, it will be EBS. So it is the elastic block storage. You can create a snapshot of your iSCSI target in generic terms, and then you can convert that into an EBS volume or maybe a virtual disk. And if you have an EC2 instance, this is like a virtual machine on AWS, you can attach that volume directly on your EC2 instance. So that makes it very easy. On your on-prem, whatever files you store, AWS will take care of the movement to the AWS in cloud. So this will be a good way for many of our customers to start with, as far as DR is concerned. And about the tape gateway, because most of us will be using physical tape drives from IBM, Dell, HP, and so and so, and you'll be taking that backup. The tapes will be having a barcode, and you'll be sending it over. To an offsite storage, let's say by using companies like Iron Mountain and so and so. And that is the tedious because you need to export your tapes from your site to the other site for the offsite storage. But you can directly use your backup software. You can configure most of the predominant backup software like Veritas, you need ArcServe, about Rubrik, Cohesity, or NetApp backup software. You have the option of creating a tape gateway on AWS, and your backups from your backup server can be directly written to the AWS virtual tapes as well. Automatically, when you have saved these tapes, those are being transported using the AWS backbone of the network to AWS S3. So you can store your tapes there, just like an offsite of storage, and you don't have to consider about a license with a new company, something like Iron Mountain, to store your tapes and so on. So in case if you want to retrieve your tapes in the future, use it just one click. Just click on your tape, on your virtual tape, and click retrieve. Automatically from your backup software from VM, ArcServe, or any of that stored, you can connect to the virtual tape library, and then you can choose from which slot where you want to take the tape from, and then you can restore your data. So that's about the backup and restore option. And we'll go with the pilot-like system as well. Which some of our customers with a little bit stringent RPO and RT objectives used to follow. So in this example, they have a corporate data center on-premise in a general terms, if we have mentioned, they might be having a web server, application on the server, and a database on the server. There might be your reverse processing servers. There might be your DNS servers, maybe an Active Directory servers, your primary and secondary domain controllers, and many sort of servers as that I sort. So in this example, so you have the corporate data center, you have web application and database here. You have a similar infra setup on the AWS cloud as well. And these instances are not running at this point because now all the clients are being served from your primary data center. So let's imagine your corporate on-premise data center is your primary and your AWS cloud is your DRM data center. And now what you do only the data real-time replication between your database servers, but your application and web servers are always turned off to save a cost. And all the customers who are connecting to, let's say, an arbitrary domain of www.example.com is now hitting your corporate data center. Now, this is the ideal scenario. We'll see what happens when a disaster strikes. So in this case, you have disaster on your primary side. The domain of www.example.com is now being served from the AWS cloud. How you do it? You'll be just doing a repointing of your DNS to the AWS cloud, because you have a public IP of your web server. You just have to point your DNS to the new public IP, and there you go. All the business users can then access your server on the go as well. And now you'll be manually turning it on, because in this case, the RTO and RP is not that very stringent. Your business continuity plan is having an RTO and RPO from minutes to hours. So there is a risk appetite which they accept, and will be manually turning on the web and application server that will be starting in minutes on the AWS cloud. But your database is already replicated from your primary to DRM side. So as soon as these machines are turned on, first you turn on the application server, and then you'll turn on the web server or any of other servers. It might be that you might have a secondary domain controller on AWS cloud. So you might want to turn that on first, and then repoint your DNS entries to the public IP of the web server on AWS cloud. So those things can happen. So where you're manually turning it on. So this is one of the model when the disaster strikes. Another model. So this is what we saw from the left to right. We have stringent RPO and RTO objectives, but the cost will be a little bit more as far as the physical data center is concerned in terms of DR. So this is a warm standby option wherein AWS takes care of the DNS repointing. AWS route the service where you can configure your domain. You can configure your DNS records of CNAME or your aliases on the route the service, and that is the one which is pointing to your on-premise physical data center. Imagine this is the production, and in this case, now all the clients who are accessing www.example.com are getting served from the route service, which is pointing to your on-prem data center. In this case as well, the database of the server from your on-premise to AWS cloud is being mirrored or replicated on a real-time basis, maybe using your DB native replication or a storage-based replication. A LAN-based replication can also work in this case. So this side, the AWS DR side is not active at this moment because all the clients are being served from the physical data center. Now, if you see here, it's a scaled down upbeat standby. These application upbeat servers are created in the cloud, but they're not turned on. And we can orchestrate environment that we can automate that in our AWS. But the main point is that it is a scale down of the standby, which means if your physical database of the server has a whooping amount of RAM and CPU, with let's say about 16 of the vCPUs and 64 of the GB of RAM, and on your DR side you feel that it's not required as a start. I'll start with 8 CPUs and about 32 GB of RAM because that's what my current on-prem utilization is. So I'll keep my infra on that purpose. I'll have my web server or application server scaled down to let's say 8 cores and 32 GB in RAM. But when disaster strikes, I'll turn this on and then I'll scale that on machine. So what happens, only pay for a scale down, infra. So not paying for 16 vCPUs or 64 GB RAM. You're only paying for 8 vCPUs and 32 GB of RAM all the time. Only when you upscale your resources, you'll be paying based on the utilization. So in this case, AWS has an specific elastic load balancer, which is not active for protection of traffic at this moment. All the clients are being served from your primary data center. Now, this happens when a disaster strikes. Your complete primary data center is down, and the users can now access the infrastructure using the Brow 53 DNS entries, but automatically it will be pointed to the elastic load balancer. You can turn on your machines automatically. Your machines will be coming up. If you have strict RTO terms, then you can automate turning off or maybe turning on of these web servers or application servers on the AWS or the cloud based on your convenience, on your business objectives. And we have another model with hot standby. If you see, it's more like a warm standby, but there are 2 active entries from round 53 all the time. Your primary data center is active. The web and application servers are turned on all the time, but it's still a scale down standby. It's not necessary that you have to use a scale down standby. If you want to configure the same amount of resources, whatever you have on your on-prem to those on the AWS cloud, you can do that as well. But if you use a scaled down version, that will save you some cost. That's all. And in this case, the Route 53 is pointing to both your primary and your data centers. If you see here, there is a 2-way mirroring and replication from primary to the DR, as well as from the DR to the primary, so that even the strict RPO or RTO objectives can be achieved with it. Now let's see what happens when a disaster strikes. So it's pretty much the same as the warm standby. In this case, we are not manually turning on the web and application server. It's completely orchestrated, using it with CloudFront. And the moment AWS Route 53 detects that the primary data center is down, the traffic will be sent to an elastic load balancer on AWS, and it percolates down to the other tiers as well. So this completes the different DR models in AWS. And with all that being said, I'll pass the baton on to Rahil, who will introduce us with Cloud NDO. And that's the AWS way of automating and orchestrating a disaster recovery, some of its requirements and benefits. And he'll be showing you a short demo as well, so that you can get to know the product. So thanks everyone for your time. Over to you, Rahil.
Thank you, Sachin. Thanks for the introduction and thanks for the wonderful presentation. So you can present, right, Sachin? So you can present and we can go through the subsequent slide.
Sure.
All right, great. So good morning, everyone. My name is Rahil and I'm working as a pre-sales consultant at Redington Gulf. I basically help partners in building solutions in the right way on AWS. So as you know, today we are discussing about DR strategy, right? What are the different DR models, how we can deploy a DR site on AWS. So it's it's good to talk about AWS tool also, what tools we have on AWS to set up a disaster recovery site. So the tool that AWS offers is Cloud Endure. Cloud Endure is an AWS company now, and it comes with two offerings. One is Cloud Endure Migration, and the other one is Cloud Endure DR. Cloud Endure Migration is well suited for one-time migration, whereas Cloud Endure DR is for a proper DR site. The focus of our discussion will be Cloud Endure disaster recovery product. So what does Cloud Endure offer? What is Cloud Endure? Cloud Endure, simply speaking, it's a tool offered by AWS through which you can minimize downtime and you can do faster recovery of your on-premises or on of your cloud servers on AWS, right? The advantages of Cloud Endure are as follows. Number one, it allows you to do cross infrastructure machine conversion. So if you are running machine on Hyper-V or if your machines are running on VMware, so that can be converted into a platform which AWS support. Number two, it supports block level replication. So entire block of volume will be replicated to AWS. You don't have to worry about uh, specifics of the server, but the entire blocks can be replicated. The storage block can be replicated to AWS. And number three, it's fully orchestrated. So all the action will happen from management console, Cloud Endure management console, which I'll show you in the demo. You don't have to go anywhere. So you can do a complete DR failover, failback, everything from a single console. And it's all fully orchestrated with, I think, no manual intervention, almost no manual intervention. We'll show that in the demo. So Cloud Endure, as if we talk about flexibility, uh, it allows you to migrate from any source. It could be physical, it could be virtual, it could be any cloud platform. So you can migrate from any of the source. It supports wide range of OS and application, whether it's Linux, whether it's Windows, whether it's, let's say, Oracle DB, whether it's cluster, all application stack is supported. And you have an option to do a failback. Not only you can do a failover to AWS, but you can also do a failback to the normal operation where your application is currently running. If we talk about Cloud Endure reliability, so it's robust, predictable, non-destructive, continuous replication. So replication will happen by itself. You just have to allow connectivity. You just have to allow certain connectivity, network connectivity, and then the replication will happen by itself. No need for manual trigger. You'll have a shorter cutover windows with minimal downtime, which I'll show you in the demo. So the cutover will be, you can minimize the overall downtime window and the cutover can happen quickly. It's highly secure for regulated environment. From security, I just want to highlight two things. So the replication can be done over a VPN connection also, and you can replicate over internet also. Both ways it is encrypted, right? But for those organization which requires replication over private connection, that is also supported. So you can replicate through VPN. Not only that, your DR instances can be launched from an encrypted volume. So you can encrypt your disaster recovery volumes right? Using the AWS KMS service, it can be encrypted. If we talk about automation, very minimal skill set is required. So if you have no experience on disaster recovery platform, or if you have no experience on Cloud Endure or on AWS, that's okay. So it requires a very minimal skill set, and there is a detailed documentation available on Cloud Endure site, which guides you step by step how to set up a disaster recovery site. So don't worry if you don't have enough experience on AWS platform. That's okay. So just follow the documentation and you should be fine. It's easy, non-disruptive. Sorry, can you go back to the previous slide, Sachin? Sorry. Yeah. So it's simple. Uh, it's very easy, and you can do testing also before actually launching the DR site. You can test your disaster recovery site uh, before actually doing the cutover. So this is one good feature of Cloud Endure. It allows you to do all the testing before you promote your disaster recovery site. Right. Yeah, you can change the slide now, Sachin. All right. So how you can start with Cloud Endure? The question is how Cloud Endure works, right? So it's very simple. You'll have multiple virtual machines on your on-premises or on your cloud platform, let's say any other cloud platform, and you want to set up a disaster recovery on AWS. The first thing to get started is to have a Cloud Endure account, right? And you should have a Cloud Endure disaster recovery subscription. Then you should have an AWS account, right? Once you have it, then you can start installing the Cloud Endure agents to your host. Uh, so it's a very lightweight agent. It supports both Linux and Windows. You can start installing the agent. You just have to allow connectivity to two endpoints, which is console.cloudendure.com and TCP 1500 replication port has to be allowed. That's all. And once the agent is installed, you can then go back to the Cloud Endure console. You will find your machine, and then you can configure your disaster recovery blueprint. Blueprint is actually a schema which says where is your source and where you're going to create the disaster recovery. Whether you're going to do the replication over internet or whether you're going to do replication over a private network, whether you want to do some throttling, what should be the replication instance type, what should be the machine conversion instance type. So those kind of things you can define in the blueprint, and the blueprint applies at the project level. So when you create a project in Cloud Endure, the first thing you have to do is to create a blueprint, and then you have to define the replication settings. Now, once let's say our agents are installed and we have configured the blueprint, we are good we are good to start the CDR, continuous data replication, and then we can test our target servers. So the machines can be launched straight away from the Cloud Endure console, and we can do all sort of testing at the application level. Once we are happy with the test, we can do the cutover. Or once we have done the testing and our production site is not reachable for some reason, we can actually do a cutover to the disaster recovery site, right? Let's understand network architecture of Cloud Endure, how it works. So we all know in the source, where you have the source, so you have to install agents. So agents are installed on the source VM. It could be physical machines, it could be virtual machine, anything, but you have to install agents. So once agent is installed, and if you have allowed connectivity to Cloud Endure console.cloudendure.com on port 443, as you can see, it will be able to make API calls, and based on that, staging areas can be created for you. I'll talk about staging area in a minute. So once the agent is installed and once you have the connectivity to console.cloudendure.com, you can create a staging area that you can define in the blueprint itself. Staging area simply means it's a temporary these are temporary resources. So this includes your replication server, and these includes your volume, because volumes will be replicated from source to AWS. So it creates a lot of snapshots, right? So your data can be captured for different time frames. Let's say after every 15 minutes, you will have the snapshots taken and you will have the copy of your data, right? Mostly it's real time, so if you're not changing anything, if you're not making any changes in the source, so there will not be any new snapshots taken, right? But staging is a temporary area which allows you uh, to have the replication setup, in a simple word. Now, to allow replication, you just have to allow TCP 1500. This is a port, replication port used by Cloud Endure, and you have to allow this connectivity. It should be bidirectional, because we may do a failback also, so allow bidirectional connectivity. And once you build the staging area, and once you initiate the continuous data replication, you can then define your DR subnets, where the DR servers will be launched, which subnets to choose from, and your targets can be launched accordingly, right? So let's, as we go to the, we'll move to the next slide, and we'll see how you will start. What is the what will be the scenario before disaster recovery, and what is the expected outcome after the cutover. So we'll understand in the upcoming slides. Right. So before disaster recovery, in your data center, on the source side, you will have your machines up and running. They will have it may have multiple volumes, boot volume A and data volume 1. Cloud Endure agent will be installed on the host, which does continuous data replication on TCP port 1500. And there is it's the staging area. It's a lightweight staging area which will be created in your AWS environment. And how it will be created, the schemas and everything will be defined in Cloud Endure, right? So this staging area allows us to have fresh copy of our data stored into the AWS. So the agent will facilitate that through live replication, and our snapshots and our boot volume will be stored in AWS Cloud, which I'll show you in the demo. Right. So this is before replication, right? Now let's say if a disaster if a disaster happens, how would you do the recovery? So this site will be completely gone, source will not be reachable, right? So what happens? The staging area uh, will initiate a failover action, right? From Cloud Endure console itself, and when you do the failover, the actual target will be launched into your AWS account. By the way, this will be when we say the targets will be launched, these that means the servers will be created. In the staging area, you will only have volumes and snapshot, but when we launch the target, the actual servers will be created with respective volumes, and these volumes will come from the snapshots which is stored in the staging area, right? So let's say if you have 3 servers here, and you have uh, volumes of 3 servers here, you have a continuous data replication happening. So when you initiate a failover, you'll get an option. What is the recovery point that you want to choose, right? You can choose the recovery point of 15-minute uh, uh, prior to the disaster, or you can choose the latest recovery point. Subsequently, you have an option to select appropriate recovery time. So once you select that recovery time, the actual targets will be launched in AWS uh, region, in an AWS region, in the defined subnets, and then your machines will come up. And once your machine comes up, you may make the routing changes and you may make the DNS changes so that your application can be served from AWS, right? Pretty straightforward, right? So I believe we can step into the demo. If I can present my screen. Hi Rakesh, can you make me presenter? Okay, thank you. So I'll just share my screen. Okay, can you see my screen?
Yes, we can see a screen, but not the PowerPoint. Or
Okay, what about the console? Can you see the console?
yes, we can see.
All right, great, great. So I'll just walk you through the setup. So we have an application, WordPress application, very simple application running in AWS in the AWS Ireland region, and we wanted to set up a disaster recovery for this particular application in Middle East Bahrain region. So if you see this application, it's a very simple website. I'll just copy the address. And I'll paste it here. See, very simple website, nothing fancy, right? So it's a simple site, and we wanted to create a disaster recovery for this site in Middle East Bahrain region. So what we have to do, first thing, we have to install agent on this machine. We have to allow connectivity to console.cloudendure.com, and we have to allow TCP port 1500. So I have done that already. And once you install the agent, you should be able to see your machine in Cloud Endure console. So the process to add machine is very, very simple. Let's say if I have to add machines, it'll tell me what I need to do. So I just have to download the agent for Linux. I have to run this command, and then if my connectivity, if proper connectivity is there, I would be able to see this machine in the console, and the replication will start. Now, before that, you have to set up your Cloud Endure account. You have to create a project, first of all, to get started. So as you can see, I've already done that in the background because I don't want to take too much of your time. So I've already done that. I've given my AWS credentials so that I can connect to my AWS account, and I've defined my replication settings. So this is what I was talking about in the slide. This is the blueprint. So my source is will be located in Ireland region. It could be any source. So if you are running on premises, you can select other infrastructure. But for me, my machine is running in Ireland region, so I've selected Ireland region as the source. My disaster recovery target will be launched in Bahrain, so I've selected Bahrain. Now this is about this is some settings related to the replication server. This is the staging area that we talked about. The replication, the block level replication will actually happen through these replication server. So we recommend to use a very small instance so that you don't incur cost. So we are going with T3 small instance type. If you need a faster replication, you may use dedicated replication server. That means if you have 20 machines in your source data center, then you can use 20 replication, which will be replication server, which will be one-to-one, which is like one-to-one mapping, a dedicated server, replication server for each of your source VM. I don't want to do that because again, it can add to the cost. Then you have option to specify the disk, replication server disk. So I'm going with SSD so that it completes quickly. And then standard stuff. So from where your replication server will be launched, what subnets to choose from, what VPC to choose from, what is the security group of the replication instance. So I have created this already. So if you haven't, you can create a security group allowing TCP 1500 and port 443. So you should be fine. Then if you are using a VPN connection or if you're using a direct connect, you can check this option and you can specify your proxy settings and it should be fine. Right. As I said in the slide, you have option to enable volume encryption. So if your compliance requirement states that all disaster recovery servers have to be encrypted, so you can enable volume encryption. And these are some of the tags that I can add to identify my staging area resources. So I've already done that. And if required, I can enable network throttling. So I don't want to do that, as I've disabled the throttling. I don't have any bandwidth constraints, so I just disabled it. If you go to other settings, it's basically project related settings and account related settings, so not relevant. Now let's talk about machines. Yeah, so we have installed the agent on the machine, and I can see this in the Cloud Endure console. Now we can do the testing. So the machines, once the replication completes, you can see there's a green check mark, so the replication has been completed. Once it completes, you will have option to do recovery, or you can do a test run. You can launch this machine in a test mode. So going back to this icon, to the machine section, you can see there are multiple icons. So when it's purple, it means the target can be launched. And if there is any error, it will be highlighted here. So you have to check the status of your machine. This is very important. So my disaster recovery lifecycle has been tested already. So I'm good to launch the target. Right. So I'll go straight away and I'll run the recovery mode. Meanwhile, if you wanted to change the blueprint of this machine itself, because automatically it will pick the blueprint from the setup. But if you want to change anything, let's say if you want to have something specific related to this machine, you can change it here. Right. So I'm just going with the default options and I'll click on recovery. One click, next. Yeah, so that's what I was talking about, multiple recovery points. So these are the snapshots that was taken when the replication started. So you have multiple snapshots to restore from. So I'll select the latest one because I want the latest copy of my application. So I'll select the latest recovery point and I'll click launch. Now you can see the job progress here, what is actually happening. Now recovery job is initiated. It is waiting for the latest snapshot, right? So if I can switch to the console, I'll show you exactly what's happening. So this is my Bahrain region. If I go to snapshot, you can see Cloud Endure is taking a new snapshot, right? And you can see the time, it's 10:58. So this action was initiated maybe a few seconds ago, and the snapshot is in progress. By the way, these snapshot, for those folks who are new to AWS, these snapshots are all incremental. So only the data changes will be captured in the new snapshots. So this should complete quickly. If I refresh the screen, it is already done. So because there's no changes, right? So if we go back, you see finished waiting for the latest snapshot. Now it is doing a cleanup of my instance because I have launched an instance in the test mode. So that instance will be terminated. 60A, 60A, if I refresh. Okay, you can see that this instance is getting terminated. So I no longer need the test instance. I'm doing a recovery. So it will do the cleanup of the test instance. Let's wait for some time. Now it's terminated, right? So next set of action will be performed. So it will try to recreate a new instance using the latest snapshot which we have taken. So we'll get a new instance ID as well. You see here, if we refresh, it should come up in some time. Right. All right. So now it's trying to launch a new instance with the latest snapshot and with the latest recovery point which we have selected, right? So this is the new instance that is getting launched. And I can see that in the logs also. So it has started the cleanup of a Elastic IP, which was attached to the previous instance. Now it is creating a replica of the instance WordPress. So it is creating a new replica from the latest recovery point. So let's wait for some time and it will come up. So if you remember, we started this job at 10:58 and within 3-4 minutes, we will be up and running. Guys, meanwhile, if you have any question, you can put in the Q&A section. We selected a really small instance, T3 small, to keep the cost low. So it's just a 2 vCPU machine. So the conversion actually would be a bit slower as compared to general purpose instances. And once the machine is launched, we can actually see in the target. So this was for the test. Now we are doing the actual recovery. So once the job progress complete, we can see the output in the target section. Okay. Now, meanwhile, I'll touch base on few other things. So let's say if you have multiple machines uh, and you want to create a disaster recovery site and you have to follow certain orders. For example, a database instance should come up first, and then the application server should come up first. The Active Directory server should come up first, and then the, let's say, SQL server should come up. So those orders you can define in the recovery plan. So how you do, you will create a new recovery plan, right? And you will add the steps. So for me, I just have a one machine. So I can't demonstrate that, but let's say if you have multiple machines here, so you can define steps, uh, restore app server, right? And you can add steps and you can add the wait time as well. If I add step, you see there is a wait time. So you can define for how long you have to wait before executing this step. So it could be 5 minutes. For 5 minutes, just specify 300 seconds and you should be fine. So likewise, if you have multiple machines and if you have dependency on certain aspect or certain machine, certain other machine, you can configure it in your recovery plan. Just discard it. Okay. This is the one. Okay, I think it has completed. Now, okay, this new instance is up and running now. And if you see the time, we started at 10:58 and we are done at 11:06. And if you have multiple machines, if you have 20 machines, you will be done maybe in 10 minutes. So this is the time it takes to, set up a disaster recovery site. Don't believe me? So I'll just go to this IP and I'll show you that I have the same WordPress site up and running from the Bahrain region. So this is my production site, right? 54.155.131.176, and this is my disaster recovery site. You can see this is running from Bahrain region, and this is the public IP that I got for this particular instance. Now, I want to showcase a quick thing, how real-time replication works. If I go to page, I think let's change the main page first. Let's go to the post. I believe this is a user post, right? Hello world post. Okay. Now I want to quickly show you how real-time replication works, and how the changes will be captured in the disaster recovery site. So it says, hello WordPress, I'm making a change in my production site. This is Ireland server. So if you remember, our production runs in Ireland. So I'm making a change here. Hello world from Ireland. Or let's just say hello world, and we'll put the time 11:09 a.m. Right? And let's update it. It's got updated. Let's verify. So you see, hello world, and we have added the time as well, 11:09 a.m. So this change happened at 11:09. Now let's go to the Cloud Endure console and see what is happening. So it says we do have the continuous data protection, so we can launch target. Our previous target was instance 8AFF. It ends with 8AFF, which is this one. Now what we are going to do, we are again going to trigger the disaster recovery site just to make sure that the changes are getting captured or not. So you would see that we will have the snapshots. There you go. We have the snapshots taken at 11:08. Now let's do the recovery one more time, and just to make sure that the changes are getting captured or not. it's already done. It's already, replicated. But let's launch the target and verify. So I want to select the latest recovery point, not at 11, because at 11 I haven't made any changes. So I will select the latest recovery point and I'll click continue. Now this will create a new job. Obviously it will do the cleanup of my previously launched targets. So if I go here to start, it will create the snapshot first. So if I go to the snapshots, a new snapshots will be created, as which you can see. The change is very small, so I expect it to complete quickly. Okay, so it got completed. Next step, the cleanup will happen. So we no longer require this recovery target. A new recovery target will be created. So as we said, the cleanup will happen. So this will get terminated. Right, this instance will get terminated, and the new instance will be created from the latest snapshot, which we'll see in a minute. Guys, meanwhile, if you have any question, you can just drop in the Q&A section. So just because we're still waiting for things to happen, so we have 2-3 minutes, so we can take your. Okay, so let's finish the cleanup of this instance. Starting the cleanup of public IP, which got attached with the instance. That public IP is also cleaned. Now it is creating a replica of the new WP instance, our WordPress instance in the disaster recovery site in Bahrain. Right. So you can see the new instance is getting created. Let's see. So you guys will be wondering, what is this replication server, Cloud Endure Replication Con? So this is a server which is created by Cloud Endure, and it facilitates the replication. It allows block level replication. And when we do the failover and failback, there could be a machine conversion process which also happened. This is not applicable because we are doing a disaster recovery from AWS Ireland region to Bahrain. But if let's say you are doing a disaster recovery from on-premises VMware to AWS, then machine conversion would be needed as well. So another replication instance for machine conversion will be created. And these are temporary, by the way. The moment your target is launched, it will automatically gets deleted. All right. So it's stopping. Okay, so it has stopped. Now it will be Now the state will change to running very soon. Pending. Now it will become running. So as you can see, now it has finished creating the replica instance, and a new public IP got attached, and a new replica instance server is up and running. So if we select the new one, we'll see all the details. It's initializing, so this server, let's wait for the health check to come, status check to complete. It's still initializing, but you can see how quickly this gets completed, right? Within 7 to 8 minutes, the whole TR instance was launched. You know, the snapshots was created, and it got attached to my new disaster recovery instance. So pretty quick. And we have taken a very small machine, by the way. We have taken a T3 small machine. So if you have a bigger machine like M5 large, or if you have an R5 instance, the replication process would be even faster, right? Okay. So yeah, the status check is also passed. Now let's grab the public IP, the new public IP. I can just copy it. This was the old one. I don't need it now. So this is the new disaster recovery instance from Bahrain region. As you can see, the new changes is also captured when we launch the disaster recovery site. This confirms that real-time replication is working through Cloud Endure, right? Because this is the change that we made at 11:09 a.m. in our primary site, which is this one. And the same is getting reflected in the disaster recovery site as well. So our real-time replication is working fine, and our console output confirms the same. Because if we go to the Cloud Endure console output, we can see the same thing. Everything is fine. So guys, this is about the Cloud Endure replication and failover process. And let's say if you have to fail back, all you have to do is to click on project action, and you can click on the failback. So what happens? It will start the reverse replication. Now the replication will start from Bahrain to Ireland, and whatever changes you have made in Bahrain region will be captured in the Ireland region when you launch the targets in Ireland. So I think that's it from my side, guys. So I hope this demo is fruitful and it's helpful for you. So if you have any question, please let me know. Sachin, over to you. So I think I've covered the demo part. So over to you.
Thanks a lot, Rahil, for your time.
So guys, if you have any question, you can put it in the Q&A section, right? We'll wait for another 2-3 minutes. If you get any questions, we will try to answer it. Otherwise, we'll Sachin, you can just drop your contact, and if there is any question related to the disaster recovery setup or anything, people can get back to you.
Sure, Rahil.
All right. All right. So thank you very much, everyone, and thanks for joining for this webinar. We hope this is informative for you, and we will see you in the upcoming webinar. So I hope you have got the contact. So if you have any questions, you can come back to us and we'll be happy to answer all of your queries. Right. Thank you.